Hey, what's up, guys? This is Sheng here. So this time, LeetCode number 1955, count number of special subsequences. Okay, so this one is a counting problem, right? So now for this one, we have a special subsequence, right? So we define like special subsequence where we will have some number of zeros and then followed by a bunch of ones and then followed by a bunch of twos, right? That's why, for example, this one is a special subsequence. This one is also special, but this one is not because there's no one after zero, and this one is obviously not special for this one because after two there's another zero, right? Which we don't allow, right? Because after two there should be only two, right? Okay, and then we're given like numbers, right? Consisting of only 0, 1, and 2, and we need to return the number of different subsequences that are special. Okay. So for example, we have this 0, 1, 2, 2. The answer is 3 because for this one, we have 0, 0, 1, 2, and 2. So we can choose either this one, right? That's one, special subsequence, and we have 2. So, right, this is the second one. The third one is this, right? Because we can choose either 1, 2, or 2, 2 altogether, right? So that's why we have 3 here. And for this one, obviously there's nothing, it's 0 because there's no 1 after 0 whatsoever, right? And for this one, it's 7, right? It's because we have 7 ways to choose. Yeah, so obviously, so this one is like a counting problem. For counting problem, most likely we'll be using some sort of DP to solve it. And so for this one, let's see, let's start with a simple case, right? So let's assume we only have one number, right? So let's say we only have 0. And what's the different ways we can choose for this 0? Obviously, this is like a full combination problem, right? So let's so for 1 we have 1, right? And for 2 zeros we have 3. For 3 zeros we have what? We have 7, I believe. And for 4 we have what? 15, I think, right? So how do we get this one, right? I mean, let's say we have dp 0 representing the number of subsequence, right, that the current dp have, right? So let's at the beginning it's 1, right? So at dp, how about dp1? It's 3. How do we get 3? It's times 2 times dp. I found some web results. I'll send them to check that. Sorry, it's my HomePod. So this is going to be the dp of 1, right, and then plus 1. So that's basically, sorry, dp0. Plus 1. So basically that's the state transition function here for the 1 numbers here, because so what does this one? It means that let's say we have 3 zeros, right, and then we're adding like the fourth 0 here. So for 3 we have 7 ways, right? 7 ways in total, but by adding one more zeros, what's the new total subsequence for this one? It's going to be basically 2 times 7 plus 1. And why is that? Because so basically by adding these 1 zeros, we have inherited all the possible ways of only choosing the previous zeros, right? So we have these 2 parts. This one of the 7, right? So we have 7 plus 7 plus 1. Basically, the first 7 is whatever we have here, because which means that we simply totally ignore the last zeros, right? That's why we can still keep at least have the previously 7 ways, right? But if we include these zeros, then we'll have like another 7 ways, because 7 means that if we this second 7 means that if we're ending with these new zeros, right? And then previously we have 7 ways, plus this 7, we have this 7, right? So this is ending. ending with this one. And this 7 means that then we ignore, right? We ignore the current zeros, which is we simply keep whatever we have previously. And this one is ending with 7. And this, how about this plus 1? Plus 1 means that, we simply ignore everything before, right? And then we only choose this last 0 as a new subsequence. That's why we have 0 here. That's why we have this 1 here, right? And then if we have another zeros comes in here, right? Same thing, right? You can use the same logic, right? So the why we have this 2 times dp 0. So the first dp 0 is is we simply ignore this one, and we will keep whatever we have, right? And then and the second one is that we end. Second one includes everything that's end with this current 0, because we have this dp zeros for the previous one. So ending with this one will be the same as the dp, right? And then plus 1 means we simply ignore this part, and then we only pick this part, right? So pretty straightforward. That's how we get, at least that's how we get this 0, 0, 0, right? With this only one number, right? And now if we extend this one into 2 numbers, okay? So if we extend this one into 2 numbers, let's say we have 0, 0, 1, 0, 0, 1, right? So for this one, let's say we have this, we're looking at this ones here, right? So if we have these 2 numbers, what does this one means? If we have 1 here, 1 means that, so ending with 1, right? So what does it mean? It means that on the left side, we can either pick 0 or 1, right? Because we have 1 here, so whatever we have here, this one could be either 0 or 1, right? So that's why, for the dp1 here, right? So if we among these 2 options, if we pick the ones, if we pick zeros on the left side, so what we'll have? We'll have dp0, right? Remember, dp0 are the zeros, are the subsequence that ending with 0, right? How about if we pick 1, right? Because if it's 0, then it means that we have dp zeros. But how about 1, right? If we make sure we want to use put 1 here, then it means that obviously we'll have what? We'll have 2 times dp1, right? So this one is very similar as the one number version, right? So the only difference is that with this 2 times dp1, there's no plus 1 here, right? And why is that? Because there's no plus 1, because we simply cannot only pick this one number, and we don't pick anything ahead of time, before, right? Because to make this subsequence a valid one, we need to have something on the left side, right? That's why the total count for dp1 will be the dp0 plus the 2 times dp1. Similarly for dp2, right? So for dp2, right? So let's say the current one is 2, right? So we have a bunch of numbers on the left side. So for this one, in order to make this one work, right? So the left one, so this one, the left one should be either 1 or 2, right? That's why we have dp1 plus 2 times of dp2. Right, again, right? So for the dp1 here, right? Since since we choose to pick we choose to pick 1 on the left side, which means that so for this time, right, there will be no calculation for 1, because whatever we have here, it will be directly inherited to 2, because we know we don't want to pick 2. We want to pick 1. That's why we have this many of combinations. But when we try to pick 2, then it means that, okay, now basically we're extending 2, right? Extending 2 means that we have 2 times this dp2, right? That's how we calculate the one number case, right? The only difference is that we cannot have 1 plus 1 in the end. Okay, and then I think that's it, right? And then in the end, we simply return a dp2, and that will be our final answer. Cool. And yeah, let's start coding then, right? So all we need is a length of 3 dp array here. So for number in nums, right? So again, if the number is 0, right? So this is the one number case, right? We're gonna have like dp 0 equals to 2 times dp 0 plus 1, right? Else, if it's not a dp, if it's not zeros, they will have the same state transition function, which is gonna be a dp minus number minus 1 times plus 2 times dp the number itself, right? And then in the end, we just do a modular of this one. dp2 modular, right? I think that's it, right? If I should pass. Cool, right? So obviously this one is of n time complexity, right? Yeah, I mean, just recap, right? So this one, it is like a DP solution. We start with a very basic case, which is the one number case, right? So we have a bunch of numbers, right? Bunch of zeros. By adding one zeros, so how many? What will be the new? What will be the new DP, right? Basically, the value for this one number case is going to be 2 times the old DP, right? 2 times the old plus 1, right? So why we have 2 times old, right? So because basically we have 2 parts, right? So the first old is if we simply ignore this 0, right, which will be the old one, and the second old will be all the sequences, the new subsequence that ending with the new one, right? And the last one is we simply ignore the previous part. We only use the new one as a new subsequence. Okay, and that's the base case, right? That's the 0 case. And for the 1 and 2 case, right, I mean, basically this one means that we are so for 1 2, right? So this one basically the left one can be either let's say for example 2, the left one can only be either 1 or 2, right? So this one is basically this one case, right? And the second one is the 2 case. So for the 2 case, since we already have 2 here, that's why we have to calculate this 2, right, by 2 times that. For 1 is we don't, because if we have a 0 0 0 1 1 1, right, and if we have a 2 here, right, whatever we have here, let's say we have 100 different ways. By adding a 2 here, it will be the same, right? But if we have another 2 here, when we're calculating this 2 here, we have to also uh, make sure, right, this part is calculated. Yeah, I think that's it. Okay, I will just stop here, and thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.